Alright, so let's look at some the sum and difference identities. I'm What we're doing is we're given this information, the problems I'm working, we're given this information over here, and we have to find this over here. Okay, I've got some other videos with dealing with the sum and difference, but they're a little bit different. It's evaluating like sine of 75, cosine 105, using the sum and difference identities. So these problems are different than those. So what we're going to do is we're going to have to use these formulas and to evaluate to find these. And in this problem here, we're looking at finding tangent A plus B, the problem we're going to work in this video. And I've got several videos that I'm going to do of this type. And what I've decided to do is do them all, do one problem per video, because they can kind of take some time to do. So I think that would be best to do one problem per video. And you might want to check out all the different videos I'm doing on this, because they are all a little bit different. I'm trying to cover all the different things you could come across. Alright, so let's go ahead and take a look at this is example 2. Alright, so I have sine A is 1 over square root of 5, and A is in quadrant 1, and tangent B is 3 over 4, and B is in quadrant 1, angle B is in quadrant 1, and they want us to find tangent A plus B and cotangent A plus B. But if you noticed in the formulas I had, there was not a formula for cotangent A plus B. Well, that really doesn't matter, because what we can do is just find tangent A plus B, and then we know once we have tangent A plus B, cotangent is just the reciprocal of tangent. Alright, so let's go ahead and write down the formula for tangent A plus B first. So tangent of A plus B is equal to tangent A plus tangent B over 1 minus tangent A times tangent B. Alright, so let's see. We need tangent A and we need tangent B to plug into the formulas. Well, if you look at this, I have tangent B. I know what that is. That's 3/4, so I can just plug 3/4 in for tangent B. But I have to figure out what tangent A is. Well, if you notice over here, they give us sine A. Okay. Well, remember, tangent is sine over cosine. So if I can figure out what cosine A is, then I can just do sine A over cosine A. So let's go ahead and see if we can't figure out what cosine A is. Now I'm going to use one of the Pythagorean identities. You've already, if you're at this point in trig, you've already gone over those. So we know that sine squared A plus cosine squared A is equal to 1. And so all I have to do is take the 1 over square root of 5 and plug it in for sine. So I plug that in for sine, and remember, this is sine A, but this is sine squared, so I have to square it, plus cosine squared A equals 1. And so if I square this, that gives me 1/5. 1 squared is 1, and square root of 5 squared is 5, plus cosine squared A equals 1. Alright, so now if I subtract 1/5 to both sides, that gets rid of it over here. So 1 minus 1/5, I get a common denominator of 5, so that turns that into a 5, and so I get cosine squared A is equal to 4/5. Alright, and so I use my square root property, so cosine A is equal to 2 over the square root of 5, or cosine A equals negative 2 over the square root of 5. Okay. Remember, the square root property, remember that from algebra. When you square root, it's plus or minus. Okay. Alright, so now we have to figure out which one to use. Well, remember, A is in the first quadrant. And what is cosine in the first quadrant? Cosine's positive in the first quadrant. Remember, all students take calculus, and they're all positive in the first quadrant. And so we know we're not going to use the negative. Okay. Now, also, if you look at this, I didn't rationalize the denominator. I'm not going to worry about rationalizing the denominator because this is not my final answer. If I have a radical in my final answer, I'll rationalize the denominator then. A lot of times when you're working these problems, it's easier if it's not your final answer, it's easier not to rationalize the denominator a lot of the times. Alright, so this is how I found cosine A. So what I'm going to do is I'm going to erase all this so I can have more room, and we'll just write down the value that we need. Alright, so I'm gonna come up here and write down cosine A is equal to 2 over the square root of 5. Okay, and let me go ahead and erase this too. Alright. Alright, so I need tangent A. Well, tangent A is just sine A over cosine A, which is sine A is 1 over the square root of 5. All that is over cosine A, and cosine A is 2 over the square root of 5. Okay, so that's going to give me tangent A is equal to, well, remember how to divide fractions. That's 1 over square root of 5 times, because remember it's this divided by this. And remember, to divide fractions, that would be this times the reciprocal of 2 over square root of 5. So that's going to be square root of 5 over 2. And you see, it really didn't make a difference. The square root of 5's cancel out, and so I'm left with tangent A is equal to 1/2. Alright, so now look at this. I have tangent A, I have tangent A. So I have my values to plug into everything. So this is going to give me tangent of A plus B is equal to tangent A, which is 1/2, plus tangent B, and tangent B is 3/4, over 1 minus tangent A, which is 1/2, times tangent B, which is 3/4. And so this is going to give me 1/2 plus 3/4 over 1 minus 3/8. Alright. Now, do we remember how to simplify this thing? Alright, this is a complex fraction. Let's write this as 1 over 1 so everything looks like a fraction. Alright, so let me review you real quick on this. Alright, so what we want to do is we want to look at all the different denominators. Okay, we have a 2, a 4, a 8, and a 1. So what's the common denominator? It's 8. So what we're going to do is we're going to multiply each term. Let me use a different color here. We're going to multiply each term by the common denominator. Okay, and so you see this cancels, we're left with a 4. This cancels, we're left with a 2. And then the 8's cancel, we're left with 1. Okay, and then nothing cancels here. So I'm left with, let's see, 4 times 1 is 4, plus 2 times 3 is 6, over, and then this is 8, minus, and then 3 times 1 is 3. So that leaves me with 10 over 5, which is 2. And there's my answer for tangent A plus B. Now, they also want us to find cotangent A plus B. Well, I was writing cosine. Cotangent of A plus B is equal to what? Well, it's equal to the reciprocal of tangent. Remember, tangent and cotangent are reciprocals of each other. So this is 2. So what's the reciprocal of 2? Well, it's 1/2. And that's your answer to tangent A plus B and cotangent A plus B. Alright, so I hope this video's helped, and like I said, I'm doing several videos on this type of problem, and they're all a little bit different, so I hope you'll check those out, and if you like the videos you can subscribe. Alright, thanks.